The brothers Wisp. The brothers Wisp, brothers Wisp. The brothers Wisp. The brothers.
You're now listening to Greg. It's the brothers Wisp.
Hey everybody, this is Greg. We have a very special podcast this go around. We have some new faces and some new equipment. I know you guys are always keen for the new equipment, the new gear, the newest, hottest thing, and they're going to bring it to you. So today we have Vladimir Kelman. He is the CTO and president of Kwikbit. There you go. Because some of these folks are only listening; it's audio only, right? So you gotta be very boisterous. Come on, Vladimir, let's hear it.
Okay. Hello, everybody.
Perfect. We also have a guest from the CEO of U.S. Internet. It's Travis Carter.
Hey guys, how you doing?
Excellent. And then we have our longtime faithful Justin Miller from VA Skywire.
Nice to meet you.
You too, sir.
Excellent. So, what is the purpose of today's podcast? We are introducing Kwikbit. I think maybe a few of you guys have heard of Kwikbit. I've seen you guys have done a little bit of press release stuff. I saw kind of with the COVID, COVID relief out in California, you guys were doing a little bit of press stuff. But other than that, I don't think you've made too big a splash, so hopefully we can change that a little bit. So, Vladimir, tell us who Kwikbit is. Well, I mean, first tell us who you are, I guess. I mean, that would be a good one. And then who Kwikbit is and why we are talking to you guys today.
Well, I'm a founder of Kwikbit. Kwikbit was renamed into Kwikbit from a company that was called Max4G, and I formed Max4G, and it did a bunch of work related to wireless data for companies like Clearwire and Bridgewave on NRE plus basis. But at one point we decided that we would like to invest in our own future and build equipment and build software that would allow us to get to the next level, the level of a provider of equipment and software and services related to broadband connectivity. We really found a huge opportunity going in the marketplace once the demand for broadband passed the level of a few megabits per second, and where 5 gigahertz equipment could not deliver, or DSL could not deliver the bandwidth that is currently is required or demanded by the market. So 60 gigahertz is technology got to the point where it became economical and provided huge opportunity to introduce something new into the marketplace. And what we focused on was in 60 gigahertz to provide equipment that would be economical as well as easy to deploy, easy to put out there, and expand bandwidth services, broadband services to customers that are closely equivalent to what fiber can do. And so that was our mission, and the Kwikbit started working on wireless 60 gigahertz equipment a few years ago. We introduced our first product about a year ago, was for indoor IoT type of 60 gigahertz communication, and then we followed with a bunch of products for the outdoor communication, and that we can talk about today.
So you touched on a lot of different stuff there. I was wondering if I could ask you a couple of questions. One being with the Max4G stuff. So, I mean, you guys have a pedigree of making hardware, right? So when you said Clearwire, that was the WiMAX stuff, right? So you guys were a manufacturer of WiMAX gear? Is that, or am I completely off?
Okay. That's correct. So, no, you're not at all. So the previous company that most of our current employees here at Kwikbit today come from a company that used to be called NextNet Wireless. NextNet Wireless was the pre-4G wireless broadband mobile data network, fixed and mobile data network. And we got acquired by Clearwire, Craig McCaw, in 2004, and deployed more than 1 million subscribers in US and around the world, Europe, like Belgium, Ireland, Canada, Mexico. We were everywhere.
Gotcha. So this hardware,
we got acquired by-
manufacturing,
okay,
this
go
stuff
ahead.
is in your blood, right? This isn't new. You guys, this is your first rodeo, right?
No. This is not the first one. Actually, we did much more than we're doing today. We used to go and design our own chipsets, right, with all algorithms of baseband and RF. So this is much simpler today when you go and you get some of those modules from Qualcomm and other manufacturers of those modules. So it's in our blood, absolutely. Software and hardware for wireless broadband networks. I was in that industry since 1989. Was the first wireless data network that I built in my life. So I have a few notches on my belt as it relates to wireless
Gotcha.
data.
Well, I think I was watching Ninja Turtles at that time, so I wasn't dreaming of making any wireless networks. So I would definitely say you've got a pedigree in the wireless industry, and as well as the hardware manufacturing industry. So you mentioned a couple of more things there. You mentioned Qualcomm. So you guys are using some off-the-shelf silicon?
We do. So as you probably know, and most of the audience here know, that there were quite a few different providers of chipsets for 60 gigahertz, and I would refer to the generation with beamforming, with phase array antennas, and that kind of technology. And when Intel tried to do something at Broadcom, Qualcomm, we have other smaller companies like Peraso, for example. But we examined pretty much all of them at a time. We also examined some of the module providers and what they have done in addition to what Qualcomm provides in terms of antenna design. And we ended up selecting as our provider is Qualcomm for the chipsets, and we work primarily with WNC on antenna arrays.
So on the antenna arrays, is that something that you guys got to have some say in, or is that something off the shelf? I mean, how much collaboration was there when you were putting? So from what I understand, the chipset is the chipset, right? And they hand you that, and I assume some kind of an SDK.
That's right.
But the antenna, did you have a little bit more say in what went on there?
Sure. So antenna arrays, in addition to what kind of patterns of transmission, whether what kind of beam you want to put together. You also want to understand how you can steer this beam. You want to understand what would be the interference avoidance. You want to understand what would be the azimuth and the elevation that you can steer the beam to. What kind of ARP you want to achieve. So we did work with WNC to take the antenna arrays that they already had and put together what's in an industry called BRD file. And that file defines how you steer the beam, what ARP in each direction would be, and things like that. So you work with somebody like WNC or any other antenna provider in customizing that per your application.
So basically you did your due diligence, you took the best in breed, and you're pulling it all together, and you're wrapping up with your long-term know-how in hardware. And you guys have a few, I think as Miller calls it, the secret sauce is in your software, right?
That's right. So our idea was to create a system that not only will perform really, really well, okay, so we had one advantage. I think one of our advantages was that we did not jump into this industry from the very beginning, where lots of other providers were struggling to put together something based on something very, very basic and first generation. So we took advantage of, for example, Qualcomm's first release was Sparrow release, and that supported only one tile, antenna tile. And we kind of said, yeah, we don't think we want to do that because the performance is not what we would like to provide as a solution to our customers. So we were looking into when Sparrow Plus came out, then we tested it and we could see that we reliably can deliver 1 gigabit per second symmetric 400 meters, and that was a time we said, okay, this actually works, this is actually stable, and this is something we want to go with. So in addition to this performance, we actually also looked into ease of deployment. And ease of deployment is how do we have a customer that can go and install units outdoors or indoors without pre-configuring them on the bench first. Because it's a huge problem when you need to go and make sure that every unit is configured correctly before it is installed. And if you misconfigured it, you have to climb the pole again and do something to it because it's not connecting to anything. So we put together a system where all the units come to the factory identical, and you will have a tool to design your network, and that tool then, the file that comes from that tool, assists you from a single point to configure your entire network that you put up. So a bunch of that software resides on an external device with a tool, but a bunch of it resides on the unit itself that allows you to do that. In addition to that, we put some secret sauce into redundancy. So we introduced the concept of a preferred hub. So a unit that loses communication, for example, to its preferred hub, it can go to alternative hub if it can see it, as long as it goes and eventually get the data to the root node. You don't want to create islands in your deployment. You don't want to create a situation where you deploy a bunch of units and they, for example, in mesh configuration, sometimes you can get to the point where you have a bunch of units interconnected between themselves, but none of them is connected to your fiber, and that's a problem. So we resolved all these issues with our secret sauce on the units themselves, as well as some assistance software on what we call the edge controller. An edge controller can be appliance, it can run on virtual machine.
I have been furiously scribbling notes. Man, we are covering ground fast. My head is spinning. All right, so.
Oh, well, we don't have much time, so I was trying to put it
I
all
hear you,
in.
brother.
I would be more than happy to provide more information for whoever's interested to follow up and
Oh yeah, for sure. No,
it's
it's the problem with me is any one thing you tell me, I come up with 10 questions. So you've told me 10 things, so we've easily got 100 questions that I'm about to fire at you. No, so I get it. So easy software install. So you alluded to the fact that you guys started indoor, but now you have an outdoor product. And I think we should talk about hardware in a minute because the guys love talking about hardware. But you were talking about easy software to install. So in my head, I'm thinking you started indoor, you're looking for easy. You probably were working with integrators, right? So I know I've worked with a lot of various integrators in various times. I know Miller has too because he kind of plays in the MDU space as well. So there's a lot of guys that do periphery stuff like security, or there's some guys that are more specialized in video or access control, whatever it happens to be. And generally those guys that aren't, I don't know how to describe it. You either have a network guy or you have basically the equivalent of your grandma who just got an iPad and you're trying to explain to her what's going on, right? And it's no knock against these guys. I mean, a lot of them are cable pullers. They're mechanics. They're engineers, right? They don't deal with the wireless stuff. And so they just want something they can plug in and all their equipment can talk. I'm assuming that's kind of your target market when you guys first got started, right?
Yes, so when we started on the indoor, you're exactly right. For the industrial IoT, people that install industrial IoT equipment, they don't know anything about networks. They just completely agnostic.
Yeah.
Those are electricians that go and connect some stuff. So what we have done is our tool that we created was you take you load up your either map for outdoors or for indoors, the blueprint, and on the blueprint you go and drag in the radios that you want to put in place, the points where you want to provide communications to. And then you can go then with the tool, connect them either wirelessly or with a wire. For example, if you want to jump over the wall, you would go and say, I want to connect these two radios with a wire, but then these two radios communication wirelessly to some other points. So you would go and design your network that way. Once it's designed, you would get from a box of radios from us, and you would give it to an electrician, and you would say, here is your blueprint with where the radio is supposed to go. Go hang them out there. They just don't do anything without hanging them and powering them up. That's it. Once that is done, you take your tool with a blueprint on it, and you connect your edge controller, so that's our software that configures the whole network, to the first unit that is connected to everything else, right? And from that point, it's tool-assisted commissioning and deployment. It's just you go and commission your network node by node until it's all connected based on the design that you put together. So that's what we did. And so we ran that with multiple customers in warehouses and manufacturing facilities where one person needs to understand the network connectivity, the one that is sitting by the tool. And the rest of the installation is done by people, like you said, the grandma understanding people in networks.
So that's the controller software you're talking about. Just looking on your website, is that the Kwikbit Edge? Is that what we're talking about? Okay.
That's right. That's right. The Kwikbit Edge, and it's a software product. If some of our customers like to have this little appliance, so we send this industrial kind of computer, little computer that you can run this software on, or you can actually load it's on the virtual machine on any server. It runs on Linux, and then you connect that to your network, and you
Gotcha.
use it.
And so that's.
By the way, edge controller actually, once network is deployed, there is a monitoring mode. You switch it to monitoring mode, and from that point on, it monitors your network and provides you alarms and does all kind of other things that can be parallel to like SNMP monitoring.
Gotcha.
Like that.
So, is the software required to do deployments? Can you get in there and just configure a couple of devices?
No, if you want to do a couple of devices, each device has CLI, it has web interface, you can go configure them, hang them up and out there and put SNMP or REST API interface to them and do whatever you want.
Excellent. So this is where I'm going to call in Miller really quick. So Miller has, I don't know, somewhere between 50 or 100 60 gigahertz links up, not just radios, but links, I would assume. So
I have 196 60 gigahertz devices on the network right now. I just looked at our monitoring software.
So dude uses a lot.
So
and so if you've got a product that's going to help monitor the wireless infrastructure, I was just curious what Miller's questions were on that sort of stuff. Like what would you want to see, and like what kind of things are you looking for whenever you're doing the wireless monitoring?
So the change of the RSSI over time, so I know that the RSSI can change based on temperature, seasonal, actual temperature of the air can cause the signal to go up and down a couple dB and stuff. But do you do any kind of like historical, this is what the RSSI has been, and now it seems to be this lower value for a certain amount of time kind of alerts? So that we can maybe see if a radio is now out of alignment or got spun on a pole or something along those lines?
Yes. So you can get, so we have a MIB that you can compile for your SNMP, and you can get an alert when your SSI drops down under a certain level. We also provide REST API interface, so if you want to utilize some tool that you can incorporate with REST API and get JSON files and to visualize them and go set up your tool to provide you alarms. We, for example, integrated with Elasticstack. I don't know if you're familiar with that for visualization. So we have, for example, when we monitor some of our customers, they would like us to monitor what they have. And so we have Elasticstack for our support team that they look at all the, RSSI, MCS levels, signal quality, over time, over temperature, all day long. So we have all that integrated. So it depends what you want to do, but all the information is available and can be available different ways.
Gotcha.
That sounds good.
This isn't a knock because my day job is I'm an automation engineer. So I work for Red Hat, and I get to play with Ansible automation all day long. They pay me to literally play with toys all day. It's insane. So whenever I see a REST API, my eyes light up, right? Because it's like
10 a.m.
the options for me to manage this thing or to do crazy stuff with this thing are limitless at this point. So I don't see many other manufacturers, especially trying to put out budget. I don't know, because it's solid equipment, but it's actually at a reasonable price. I don't know what do you call that? It's not budget. It's not, I don't know, whatever. Reasonably priced equipment. I don't see many manufacturers putting out a REST API with their infrastructure. What was the driver for you guys to do that? Just curious.
Well, okay, so the first driver was that we found that it's the best way to communicate to the edge controller.
There you go.
Right? So edge controller can get all the information to the network with REST API. It's connected to the network. It's great, right? So why don't extend it to our customers to use it? So then we integrate with the LSTP. So there you go.
Well, I mean,
it's a modern way to do it, you know. It's easy to extend REST API. When you do SNMP, for example, we provide SNMP, but with SNMP, you do modification, you have to recompile the map, and you can do, it's kind of the older way. With REST API, you provide as a function, you can integrate that function independently of whatever you were doing before. It's just a different way to do it. I think that many modern data visualization systems, as well as monitoring systems, relying more on REST API, we decided to go that way.
Yeah, so I run some MDU networks, and I wish all the equipment I was touching had REST APIs. I mean, I still automated against it, and it's still doing right. It's less functional, less elegant, I guess. With RESTful APIs, you can do infrastructure as code so much easier, right? Where I can have my configuration, like this is what I want it to look like. Make sure the equipment looks that way. It just makes those things, stupid simple. And I wish more manufacturers would adopt this, just a standard interface that I can say, hey, make all of this kit look like this, keep it all in my CMDB. I don't have to think about it anymore. I don't have to reach out to the equipment, try and do some reconciliation. Are these things supposed to be there? Are they not supposed to be there? What happened when? You just have a master file where everything lives, and it makes it so on the environment. So I love that you guys are going REST API first. That really was like a huge checkbox for me. I don't know that everybody's there yet, but I'm fascinated by it. So
if someone wanted to go look at the endpoints that you have available in your REST API, where can they go to see that?
So the
REST API endpoints, like the stuff that you make available through the REST API.
Oh, just the documentation.
Go to see that. Yeah,
all the
documentation for that.
Well, we can provide you that. We have a manual with REST API defined, and we can provide you the manual right away. Not a problem. We can. I don't know if it's downloadable right now. It's probably downloadable for some of our customers, but if you would like to see it, no problem. We can deliver it to you.
So you have like a customer or a portal that you have that's not linked to from your main page, or?
I need to check with. I'm technology CTO. I need to go and see what support guys and marketing guys are doing. But,
I like to go and look at the support documents and the manuals and stuff before I make a purchase, and I don't see that available
just dig around
on the site. Just poking around in 5 minutes. I didn't see it.
Justin, we'll make it available, and it's going to be available. We're currently kind of evolving our website so that what is available to our not customers, what is available to our customers,
Yeah.
But in the meantime, if you would like to see documentation, we'll be more than happy to provide it to you.
Okay.
All right. So let's get to a little bit of the hardware, and then we can kind of layer in some of the software stuff. So we talked about you started with indoor, so I guess we can talk about the indoor stuff. I don't know. I was going to say we have a huge chunk of wireless ISP operators, right? That's kind of the market we talk to, but we also do a lot of guys that are MSPs, managed service providers. So they're doing stuff kind of all over the place. And integrators. I know there's some integrators. There's some VoIP guys. So I think everybody would still be interested in listening to you guys talk a little bit about the indoor, seeing as though that's where you got started. So looking on your website, it looks like you have K60i. That's the indoor unit. It's got 3 gig ports. And as you alluded to earlier, you guys can kind of, if you need to go over a wall, you can hop from a wall to another access point. to get in there and actually utilize that stuff. You know, what's something that's interested me on this guy is it says it's PoEN 12 or 48 volts. So that's like what do you call that? Like just passive PoE? Is that the idea on that? So it's not like a standard space then, huh?
It's okay. So the indoor units were built primarily for we had a large customer that was deploying industrial IoT sensors, and they had gateways that needed to be powered by this PoE. So what we designed was this small unit. It's 4 inches by 4 inches that covers 90-degree sector, and then we have a mounting bracket that can be installed in high bay kind of environment, sitting environment, or even an office environment, and you can hang from that mounting bracket 1, 2, 3, or 4 of those units, depending how much got me this unit, right? So this is the one. So you hang 1, 2, 3, or 4, and interconnect them because we have 3 RJ45 connectors, and so you can interconnect between them as well as connect to them any kind of application equipment such as gateways or Wi-Fi or cameras or whatever you want. Now each one is powered by actually 48 volt. It's actually 12 to 48 volt power supply. And the reason we did that is, in many cases, you have either light, you have power to the lighting system, or you would have power to secured, for example, like an exit signs that are always powered, right? And so you would install one of those next to them and then power one of these units, and then with PoE power the rest of them. So this kind of what it's basically a building block for a network that interconnects wirelessly or with wireline, but with jumpers for the indoor installations. So we have installations like that again we have warehouses, primarily warehouse manufacturing facilities. We have a couple office space installations as well, where they wanted to didn't want to go and run cables and just wanted to have wireless connectivity between different areas in the office space, but primarily it's for high bay warehousing.
And looking at that small unit, even though it's an indoor unit, you got some pretty massive heat sinks on there. So you guys thought of that in advance.
Well, it's true. And the reason for that is when you go high bay in Arizona, the temperature up there gets to 125 degrees, right? So you need to be able to cool this thing that is sitting there because there's no air movement. Yeah. Remember, it's indoors. So if you compare it to the outdoor device, so here's an outdoor device. Look at the heatsink on this versus this one, right? So and they're rated to the same temperature. So there you go. Yeah, there's difference. You need to accommodate for that.
Like you said, you have that deep well of radio engineering knowledge. So yeah, you've obviously run into that in the past. Looking at your units, I also see PoE out listed on all of these, and they are at a minimum they're standards based. So it's AT, and some of them have AT and AF. So I think that's brilliant that you're going to have a standards based output on these things, because there are so many instances. I guess you guys were talking about IoT, so I'm assuming some of the applications I think you mentioned were like in urban environments, cameras, like having camera systems. So you'd be powering cameras and various probably sensors and things like that with these. Is that generally what you see folks using that for?
Exactly. So even Wi-Fi access points. We have one installation when we power up wireless access points with PoE out from our device, so you don't have to run special power to the camera or the Wi-Fi access point or any kind of other gateway that you would have. And we have, for the outdoor, there are different. Here is 2 of our units for the outdoor. The 60X unit and the 60 unit, and you can see that first of all, the 60X, there are 3 interfaces, one PoE in, PoE AT, UAF out. This one is PoE in and PoE AT out, only one port. So it depends. Also, the 60X unit has you can see the heatsink is more beefy. So this one has a hotter processor. You can do packets per second, higher rates. Also, it has 2.5 gig ports. So if you want to stream in one direction over 1 gig, you can do 1.5 gig one direction, 300 meg another. Whereas with this one is 1 gig port, so the most you can go in one direction is 1 gigabit per second. So the differences between them depends on what the customer needs. I don't have it with me, but in the WISP this month, we're going to bring in the additional 2 units in that we currently are NFCC approval stage, and they're going to be approved by the end of the month. And those customer premise units with a single 1 gigabit per second, 1 gigabit port, and but still have the performance of 400 meters, up to 400 meters connectivity.
So you talked about you have for outdoor units, you have a K60X and a K60. It looks like on your website the K60X is retailing for $499, the K60 is $299. The X series, which I guess is going to be the beefier, what you would probably be using as kind of the access point or the hub of the network, right? That's going to be 2.5 gig ports and then a 1 gig port, and then the other unit has 2 gig ports. So I'm curious on these multi-gig port units, can you do any Ethernet bonding like LACP? I'm just curious if that's an option.
No,
Okay.
that's not an option at this point. And actually, the K60X is primarily for distribution. Okay. So I would actually, if you have a hub and you want to go and support 3, 4, 5 customers, I would probably go and install the K60 unit because it's more than capable of providing 1 gigabit per second. Whereas 2.5 gig, if you want to go down the street and really stream one direction, really in the evening everybody is watching TV over 1 gig, this unit can actually do that. You interconnect 2 gig ports from one to another and you can daisy chain them and actually complete a ring because we support RSTP. So you can complete a ring and then have some redundancy as well. So this is kind of the 60X distribution. That's how it's
Gotcha.
You can okay, by the way, all our units can be either hubs or remotes. We don't even the K60C that we're going to come up with right now, the customer premise equipment units, can be hubs or remotes. We don't restrict throughput and we don't restrict how you're going to deploy your units. They can all be whatever you want.
So if you've got one acting as a hub, how many clients can connect to that hub?
The 8 clients. So this is kind of a Qualcomm current, the 11AD limitation. With 11AD, it's 8 clients.
Okay. Okay. Let's see what else. Something you were talking about earlier is you chose a specific antenna element, or a specific antenna array, and there was something special about it. It has actually 128 antenna elements, right?
128.
Right. And so most manufacturers have a fraction of that, right?
Yes. So that is correct. So I don't want to talk about specific manufacturers, but I've seen some of them with 30 antenna array elements, and some others go to like 64. We do 120 actually in our indoor equipment because we don't need to go 400 meters for the indoor. 100 meters when you support 100 meters is plenty. We have a 64 element antenna array. But for the outdoor, to get the performance, to get the what we were shooting for is to be able to get the maximum ARP that is allowed by the FCC, which is 40 dBm ARP. So on the transmit side, and then get the most gain for antenna, beamformed antenna on the receive side. So we could achieve that. We can get additional performance for both transmit and receive with 128 patch antenna array. If you can go actually beyond that, but it's only going to contribute to your receive side antenna gain transmit your limited 40 dBm ARP anyway. So for the size and heat dissipation and the price, we decided that we test it and we can support 400 meters with all our units for the outdoor, which we thought would be a good application. So with current size, right? If you do a dish, for example, some vendors go and do higher antenna gain, but then it becomes a dish kind of device, and I'm sure Justin have seen some of those from other vendors. We decided at this point it's not our application, but we may rethink that and we may put together a dish antenna so that we can.
Something I was always curious about is taking this 60 gig equipment that's really designed. I mean, it's really designed to just point in the general direction of another 60 gig piece of equipment, right? So what happens when you turn it backwards and point it at a dish? Does the beamforming, does all that still work right when you're pointing at a dish? I was just curious.
Well, it's a good question, right? So I was wondering myself, because what happens with the dish is basically you're pointing antenna backwards and the dish is a reflector, right? And the reflector will give you the gain. So how beamforming works with that? I am skeptic. I did not test it, okay, and I did not run analysis, so I don't want to speculate. But it was just a question that occurred to me, and I was curious. You know, it's I knew they weren't designed for that. I was just curious how it worked.
The antenna that you have, or the grid of receive patches, it's flat. It's about the size of a stamp, probably, or is it bigger? Like, how big is the actual element, and is it flat? And how do you get different directions out of a flat patch of antennas if it is flat?
Okay, it is flat. So it is flat about inch by inch. Each one of the antenna modules. There are two of them. Each one 64 patches, and they have to be installed because it's millimeter wave. Every millimeter here counts. Okay, so it needs to be those two modules need to be put together very precisely. Now, how do you steer the beam? You steer the beam by activating what they call sectors. In each sector is a combination of the modules that you energize. And you energize them at different phase. So by energizing different modules at different phase at different time, it put together a beam in the direction that you want. Okay? So that's pretty much how it works.
It seems counterintuitive because it's like a flat stamp with just a bunch of copper patches on it, right? And how do you get different directions out of that? It's amazing that they're able to do that.
Yeah, because if you think about this, so let's say you activate different patches at different times. Okay, let's say you want to put a beam a certain direction, then you would go and you would construct what is called again a sector, which is number of patches. Not all the patches are activated. Bunch of them are activated, and they're activated at different power and a different phase. So the product of that would be a beam that goes in certain direction. Okay? And then you go and select other patches to activate different phase and different power. You will be putting together a beam. The product of that would be a beam in different direction. So the whole brain behind that is how can you go so fast, make a beam that would be steered from one subscriber, from one direction to another.
Boom,
and
boom, 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 boom.
Exactly.
Yes. Yeah.
Exactly. How do you do it so it does it in nanoseconds, time frame? That's the whole. That's where the industry came to. It's hundreds and hundreds of engineering hours that were spent on putting something like that. Because phased arrays, it was really hard to achieve even 5 years ago. It just was technology. The processing power was not there. The silicon was not there. It was, and now remember I mentioned the BRD file. So that is actually a file that defines the sectors that you are going to be using with your antennas and how you're going to put the beam together.
Is that burned in at the factory, or is that something that you can change out in the field?
There's something you can load when you boot up your equipment. So if I want my equipment tomorrow to behave differently, I can go and work with my antenna manufacturer on what I want to achieve and create a different BRD file to load an equipment upon boot time.
So hypothetically, you could make a file that would make it more focused, or make the width of the beams more focused to get more gain, perhaps?
Perhaps I can do that, but then I would have to compromise on something else. You know,
Yes.
it's just like a balloon with water. If you push on one side, it pops on the other, and you know, so you have to massage it in the way that you want it, but you cannot get it all. Okay,
Yeah.
You cannot get the coverage, spheric coverage, at the same time have beam in every direction to be the same gain. You know, it doesn't work that way.
Yeah. Okay. So there are some other manufacturers that have tried to use multiple antenna phase arrays. One in particular has 3 of them in their device. What kind of challenges did you have coming up with just using 2, and have you explored using 3 or more?
Okay, so the only other manufacturer that I know of that uses 3 antenna patches, each one 30, 3 antenna modules, each one 30 patches, is in what's called a diversity mode. So you don't take advantage of all 3 of them at the same time. You just can go and jump your beam from one to another. And what it does for you, it allows you to have coverage of, like, for example, if you install them at 60 degrees one to each other, you can cover 180 degrees that way. Okay,
Yeah.
Each one 60 degrees. So that's what you can do. Okay, actually not 45 degrees to each other. So you can go and each one cover 60 degrees, altogether 180 degrees of coverage. But it does not provide you more gain in every direction. Okay?
Right.
So we could do that, and we actually were thinking of doing something like that, but we would not want to compromise the range performance, especially when you want to accommodate some of your ERP to when you install in the areas where you have rain. So obviously the rain has some absorption. So if in dry, nice conditions, you can go 450 meters. When it rains, it would drop down to 350 meters.
Yeah.
So if you have antenna that is only 30 patch antenna, 32 dBi ARP, then you are down to about 100 meters and 120 meters, and that's kind of, sometimes unacceptable. So we decided to provide a better reliability. And if you need to cover 180 degrees, get 2 of our units that are not very expensive.
That's interesting. So we were talking about distances. You said 400 meters. That's what, about 1,300 feet-ish, somewhere in that neighborhood? Okay.
Yep.
And is that in only a point-to-point scenario, or is that where you have a hub and multiple remotes? You can have 2 remotes that are both, that distance away.
Right. So we provide in our tool, in the design tool, you can go and select. There's two parameters that you select. You select the rain, what kind of rain profile you want to install in. So if you want to get your 1 gigabit per second, depending if you're in Seattle or if you're in Phoenix, right? So it would be different. So the tool would accommodate for that. In addition to that, the tool would accommodate for whether you are shooting bore side to the other unit, or you have units that are 45 degrees off. So if you go off of a bore side, there is some degradation of ARP into that direction, or some or antenna gain, okay, so to speak. So tools provide you with an arc that is not just a 1/4 of a circle. It actually bends the sides so you know exactly what the coverage of your remote would be. Okay, so if you have one remote 45 degrees one direction, 45 degrees the other direction, you're probably going to be somewhere about 360 meters on the edges, about 400, 405 meters.
I'm loving
outside.
the idea of this tool. Because a lot of manufacturers will give you equipment and they'll say, hey, you can do these things, but your tool is actually helping people to be successful, right? It's like,
we don't want people to come back and say,
Yeah.
you sold me something, you said it was 400 meters, and now I've installed it, doesn't work. I want my customers to come back to me and say, I want more of your equipment.
And you're really just helping them be successful and I guess lowering your support calls as well at the same time. So it's a shrewd move.
Exactly. I cannot sell these units for $499 even, and then if I have to answer phone calls and problems and resolve problems with customers twice a week, I will go back. So I need this to send to Justin, and I want Justin not to call me ever.
That's what we all want, but do we get it? Yeah.
So I will do everything to achieve that goal. That's my, as a manufacturer, as a technologist, my goal is to provide Justin and any other customer all the tools they need in order for them to be successful.
Gotcha.
Absolutely.
Well, we have our silent guest here, Travis. It's time to throw him in the mix. So Travis is a user. He has been actually using the equipment out in the field. He has real world experience, and I'm just curious, Travis. One, what are your applications? What were the challenges you ran into, and what were the positives? Just curious what your overall experience is so far.
Sure, thanks, guys. Let me might help if I just give a little bit of frame of reference of what we're doing.
Yeah.
U.S. Internet's network is predominantly in the Twin Cities of Minneapolis and St. Paul, so we're up in Minnesota here. So we've got a few interesting challenges. We've got 4 full weather cycles here, and since 2006, we've been running a municipal wireless network in the city of Minneapolis. So we've got 2,500 access points running in the city. And historically, what I like to say pre-Netflix, those nodes were hooked together wirelessly. So we would create these wireless rings of, say, a dozen access points back to an egress, and then we would drop off to some sort of backhaul radio to go from there. So we're kind of a WISP, but it's more like a microcell kind of configuration. So if you drive around Minneapolis, you'll see on every other street corner, you'll see our equipment. So what's happened over the years is, as you guys can probably imagine, the biggest challenge for us became backhaul. How do we backhaul from these access points and bring it back to an egress point and ultimately onto the internet? Mm-hmm. So about 10 years ago, we started to bring fiber to all the poles around the city. So we've, and while we've been doing that, we've been dropping fiber off to all the homes and businesses and MDUs. And so we're in front of about 140,000 homes right now with our fiber plant, and which affords us for about a third of our nodes. So let's say 1,000 of our poles, we have fiber to all those poles. So as you can imagine, those poles are very boring. You just put an access point up, drop fiber into a switch, and
you're done.
You don't do anything. So we coined this technology, as WISPs will know. Wireless can be challenging. Wireless can be finicky. Wireless can be problematic. We've used every vendor under the sun, and we now our mantra for the last 4 or 5 years is boring. We want to put it in, turn it on, and quite frankly, cash checks. Okay. So, but as you can imagine, in the winter, it freezes like an ice cube up here. And so we have a problem delivering fiber to homes in the winter. We have a problem where we have saturation on our network. And then we have problems like most cities do in a downtown corridor where you don't have the nice grassy public right-of-way to construct in.
Right.
It's all concrete jungle. So taking all 3 of those, and we started running 60 gigahertz and 80 gigahertz from rooftop to rooftop. So we had about 400 links up and running, rooftop to rooftop in the downtown corridor. And we started to want to bring this down to the street level. So the street level created a little bit of a challenge because there's a real big aesthetics problems. Vlad, if you hold that device up, this aesthetically, it's very easy to get the municipality
Oh,
to
yeah.
approve mounting this on a pole.
It's like 6 by 4
versus
inches, right?
It's like nothing, yeah.
Yeah.
So we use the Kwikbit technology in a couple different applications. We use it in a point-to-point application in an area we don't have fiber, and we get saturation on the backbone. We will upgrade the 5 gig radios we're using between the 2 points with 60 gig as long as we have line of sight. And then in other applications where, let's say, you look down a street and it's all concrete. So just to give you an idea, we did a 80-foot construction of fiber from one side of a street to another in downtown Minneapolis. It ran me about $28,000 to do that.
How long did it take you to get it done, too?
Oh, well, yeah, and it takes an act of freaking Congress. And so anyways, so the challenge is we have these all over the place. So instead of dropping fiber everywhere, we'll bring fiber to the corner. We'll shoot a Kwikbit up on the pole, and we'll shoot down the street, and we'll pick off the security cameras, the shot spotters, and all the businesses on that street. Nice and boring. You know, just plug and play and let it fire. So we really think that this is a real crucial component for us because it complements the fiber platform that we have, and it also to allow us to get to areas a lot faster, deploy a lot quicker, and honestly, they're pretty cheap. I mean, they're really cheap for what you get.
Right.
This isn't some. I mean, we've all been to WISP before. This isn't like that cheap Chinese junk you get and you put it up and then you're back there every 6 months and there's firmware updates that are a freaking nightmare to do. I don't have time for any of that, right? It's because that follows your reputation. So the hardware's been good, stable. I mean, you can see how it's built, and we just pick and choose. It's one of our Legos in the toolbox for us to get this connectivity out to our end customers.
So you said it gets cold. Does like the topsoil freeze and you just can't physically put fiber in there?
Yeah, I need to invite you up here in February.
Dude, I'm from
the top foot.
I've never
the top 2 feet freeze.
Oh
I mean,
my
we
God.
literally use
We
literally use jackhammers to get into the ground in the winter, and then we use something called a frost burner. Do you have a grill?
Yeah.
You know, like you cook on. Yeah. Take a grill, flip it upside down, put it on the ground, turn it on for a day, and thaw the ice out. And then come back, dig your hole real quick before it freezes to get down to your fiber
That's
plant.
insanity.
It's a heck of a lot easier to hang a couple radios up on a pole, to be honest with you.
I've literally seen a dusting of snow on the ground. I live in Texas, right? So it's not. It does. I mean, we get ice a little bit for like a day or an afternoon.
Oh, yeah, no, yeah, you wouldn't be. Yeah, it's ridiculous here. It's great from the standpoint that we can test equipment because we get 4 full seasons. But it's a real challenge sometimes for the gear. And that's why when we run some of the really low-end gear, it runs fine all summer long, and then it starts to freeze, and then we're scrambling trying to fix it because it really wasn't designed to run at -20 Fahrenheit.
Right. Golly. So I'm assuming you guys, so this is interesting. So you can take your equipment, you can put it out in the winter. So, you talk to the customer, hey, I'm going to light you up now with this wireless stuff. Once everything thaws, I guess, man, you guys must go crazy in the summer doing construction, and then you will build fiber, I guess, and replace some of those links, and then I guess you just pick those links up and then just move them on down the road to some other place, right?
Yeah, I consider this kind of tip of the spear. This allows us to get in, because imagine somebody's cable TV contract ends in February, they call us up to get service, and it's like, okay, well, you have to wait till June. Well, that's not necessarily a good answer.
Yeah.
So we throw a radio up, shoot it down the block, put a little not an access point, a client on their house, and off they go. And in some cases, we never go back, because it meets the needs. In other cases, we replace it with a fiber cable, take that access point, move it to another part of the network, and just keep going down the road.
Gotcha. What was this like for your installers? I'm just curious too, like from their perspective, right? Somebody never touched the kit, from 0 to 60. How long do you reckon it took them to kind of get up to speed with using it?
I think we had our first point-to-point link up in about an hour.
Okay.
There's nothing. there's nothing to it. It's not like a lot of the 5 gig like PT, the TDD stuff where you're like adjusting timings and all this type of things, and you just basically hang them up, do some simple configuration, and they start passing traffic. The most complicated thing for us was we have some links we want RSTP on, we have some links we want RSTP off. So that's our big decision criteria that we make. Other than that, honestly, it's super, super boring, and I'm super happy.
That's awesome.
With it.
How about
because it just needs to move ones and zeros through the air. That's all I needed to do. I don't, I used to be super nerdy into how it all worked. I don't even care anymore. I just want it to work. Right.
Man.
I just don't want. I want the happy customer that doesn't call up or doesn't post crap all over the internet to make us look bad. Yeah, that's all I want. So, and I'm very happy.
I'm with you that. Like I'm a guy now that buys a vehicle with a warranty. If something makes a weird noise, it's like, hey, this is your problem now. I'm gonna drop it off and let you take it.
Yeah. We used to call it drive-by. Yeah, we call it drive-by light. When the check engine light comes on, it's somebody else's problem.
Yeah.
It's not mine anymore.
Well, you know what?
Yeah,
it's funny. You start calculating how much your time is worth, right? And it's like, does it make sense for me to waste all this time turning these knobs and screws? If I can find a better tool that's going to do it for me, even if I have to pay a couple of more dollars, I mean, it's totally worth it. So another thing I'm curious about is your experience with dialing these things in for your longer distance shots. I'm not sure if you've done any significantly long shots, but just how do you find the aiming experiences on either end?
Well, did you guys ever have any of the old stuff where you had like the rifle scope? Did you ever do any of those where you'd like rifle scope them in and you'd have to really tweak them super close? And then, of course, the wind would start blowing and then the connection would start failing. These are honestly easier to line up than like a 5 gig backhaul. You just line them up, you kind of eyeball them to each other, and 99% of the time it's on. It's either on or it's not. That's the cool part.
It's a shotgun approach, is what we call it.
Yeah. And
if you can hit it with a shotgun.
Yeah, and that's the reality. And our installers, they've done this so many times. Now, if I did it, it'd probably take a while. But our guys, no, it's not a problem. But those old, like, what the hell were they? Like the very first like Siklu's we had, and you were trying to like line them up between building to building. Those were tough. But this antenna thing that they have is pretty good now.
The ether halls can be difficult, but they're also 70, 80 gigahertz, the ones that we use. So
So that's what I like about this. This is because remember these poles, they move too. We'll be on traffic lights. We'll be on all, they're swaying. They're swaying. The utility poles are not as stable as like a building is. So there's that is not our biggest issue is just line of sight. You just had where this widget works, or what we call our Lego piece works, is on, and you guys have never seen this before, there's what are called snow emergency roads up here in Minneapolis. And what these are, they're wider, they tend to have less tree coverage, they're usually concrete from edge to edge. And this is a perfect application for us. Overseas they'll call it like the high street. You'll have like little shops and gas stations and things. You'll have, and so this works perfectly. We just put them back to back, one north, one south, and then off we go. The city surveillance cameras, the water meter readers, the shot spotters, they all hook right up on these snow emergency roads.
So how about latency over these links? Have you seen it really introduce anything in there?
Virtually nothing. It's nothing like TDD, how you get like 5 or 8 milliseconds, latency. Yeah. It's nothing like that. It's less than, it's more or less like an Ethernet cable. Yeah. It's very little. Yeah.
So you're talking about like the time division multiplex algorithms, right? Where it's like kind of a shared between multiple clients. And so that's always a sacrifice, right? It's always a compromise to give clean airtime to certain clients and stuff like that. You're going to introduce latency, or you can tweak it to where you get more bandwidth, but then there's higher latency. And so it's always this weird,
you
shell
want
game
to
you're playing.
Download, you want to try to use flexible, which never works quite right. It's just, this isn't like that. Obviously, you guys are probably like us on the 5 gig side. We do all that. So that's where we get most of our latency. But the fiber and the 60 gig backhauls are virtually nothing.
Perfect. So I know,
and that's when I first met Vlad. That's why I told him I just want a wire. I don't want anything fancy. Don't get too cute. I want a wire that we can manage. Now we happen to use SNMP to manage it, but I don't want anything I want to say, okay, my fiber cable comes out of the ground here, and I want it over here. Ones and zeros, that's all we need. And if it falls out of alignment, we'll drive our truck out there to put it back in alignment. Other than that, don't get too cute.
So what are you guys watching on your SNMP when you're monitoring these radios? I mean, I assume you're pinging and make sure they're alive, but as far as SNMP goes, what are you looking for?
Signal strength generally, just to make sure that, because like things will be ticking along year over year over year, and that one tree just finally grew tall enough, or the branch just grew wide enough that it's right in the way.
Or there's a bucket truck in front of the radio.
Oh yeah,
I had that happen.
I remember on
crane fade is a thing for us.
Yeah, when we were doing 2.4 and 4.9 back in the day, every time the city bus would drive by, you'd lose all your connections. That's it. It's more environmental than anything else, which is why when you get deep in the neighborhoods where Minneapolis is like it's like a jungle, we can't really use them there. We use them more in the downtown corridor, these snow emergency routes, rooftop to rooftop. We'll use them in like large MDUs. Never figured this out, but every large MDU we go into, they always want to have Wi-Fi down by the pool.
Yeah.
But no one ever designed anything. So we'll shoot a quick bit down to the pool and then do a simple access point. So those kind of things is what we'll use it for. It's a tool in our. We try to minimize the number of pieces in our network, and this is just one of the tools we can use, and we use it where we can.
That's cool. I like the idea of kind of set it and forget it, the GUI design tool. What do you think about the design tool? You guys use that much? I mean, it doesn't sound like you have a lot of need for it.
No, we have not used it. Vlad and the guys said, hey, you want to look at it, and honestly, how our guys design it is they go to the pole, they look at the other pole, if they can see it, we're good. It's been designed.
Yeah.
yeah.
Sometimes your design happens on Google Street View.
It's exactly it. We just don't. If we were doing like a green field.
Yeah.
But ours is more I like your shotgun. Ours is more shotgun approach.
Very cool. Very cool. Well, Miller, I know I asked you a couple of questions. Do you have anything else that you're holding back there?
I do. Which channels do you support?
The 3 channels that everybody else does.
Okay.
There's kind of Qualcomm with 11AD. They support 3 channels, so that's what we can support at this point.
Okay. So no channel 4, 5, or 6. No 66.
That's correct. At this point. Yeah, so the next generation, the 11AY, would have channel 4 in addition to the first 3. So it's going to be 1, 2, 3, and 4. But currently with 11AD, Sparrow and Sparrow Plus is just 1, 2, and 3.
Okay. What's the typical power consumption of one of these radios? Like how many watts does it consume?
It really okay. First of all, if without PoE out, you're talking about consumption of the radio itself. Okay, so this radio, I think 11AX consumption is somewhere about 16 watt.
Okay.
And the K60 is about 10.
Wow.
Okay. Do you have any plans for models with SFP Plus ports? Specifically, probably the X model.
Say it again. I didn't get it.
This is really a question from Mike Hammond. Do you have any SFP pluses on your radios? Do you have any plans to do that?
So you can go fiber straight into the radio.
Yeah, fiber into the radio. Fiber to the radio.
Oh, the SFP ports, you mean?
Yes. Small form pluggables.
Well, so we did consider to put, instead of 2.5 gig ports, copper ports on these units, SFP ports. The problem is, first of all, it's more expensive.
Yeah.
Second of all, it takes more space. And third of all, if you can see, we have really, really nice sealed IP67 sealed connectors that go for RJ45. Only recently we found one that would be very compatible to that with SFP.
Okay.
So we wanted it to be, without any glance, something big. We wanted it ergonomically very, very nice and small, with nicely sealed connectors, and that was one of the driving decisions. So, but can we put SFP? Yes, that was already discussed, and actually a couple customers asked about that, and we may have an SFP port on distribution is on a 60X in the future.
Do you have any plans to support higher MCS levels?
Currently with 1180. Okay, so historically, initially Qualcomm released 1180 with MCS levels up to level 12.
Yeah.
And then later on they found out that there is lots of instability when you go into the field and you have this MCS level changes in the field all the time, and that created quite a bit of latency reduction and all kind of things. So Qualcomm actually, in starting with release that about 8 months ago, they would not support. They would support only MCS up to MCS 8. Okay. So right now we support up to MCS 8, which is about 1.86 gigabit per second combined between uplink and downlink, and that's what we do. We did, it was early equipment, we tested with higher MCS levels, and frankly, if you have a customer that within 100 meters, you may be able to take advantage of a higher MCS level, but anything beyond that, it's pretty much MCS levels beyond 8 are not usable.
Okay. That's about all I had written down right now.
All right. I have a question. Is where can I buy this stuff?
Well, I need to talk to what I'm hearing from the marketing department is our online store is going to be open next week, so you can actually go and buy it online, put your credit card in, and we're gonna ship equipment to you.
So you guys, is that your ultimate plan is to always sell direct, or are you going to go through distributors at some point?
At this point, to maximize value and minimize cost to our customer, we would like to sell direct. We don't preclude of going through distributors in the future. We actually do talk to some of them at this point, but we'll see what the terms are. But at this point, we will maintain our store, and so we sell direct. I think it benefits the customer. Customer deal with us directly. They get information from us. They get all the support from us, and they get a better price.
So do you guys? So all of the equipment we've talked about, the indoor unit and the 2 outdoor units. So these are already being manufactured. You guys are already sticking these on the warehouse shelves, or what?
Yes. So all the units I showed you, the indoor and two outdoor units, and one the indoor unit, those are FCC approved, manufactured, and they. This is actually a real unit with you can buy. As I mentioned before, there are going to be 2 more units in what we call K60C and K60C Plus. So those would primarily they're targeted for as a customer equipment unit. They are smaller. They're IP65, not IP67. They will be less expensive, yet less expensive than the K60 unit. We'll have a single PoE in 1 gigabit per second connector. The K60C would have a single 64 patch antenna, so it would not achieve the 400 meter range. If you don't need 400 meter range, you only need about 280 to 300 meter range. You can actually save some more money by buying K60. K60C Plus has the same exactly antenna array as the K60, and you'll be able to achieve 400 meters with that unit. So it depends what you need. You'll have flexibility getting one or another.
Right, rock and roll. That sounds awesome.
Thought of something else. Do you have any kind of automatic game control in your radios? So if they are too close, does it back the signal down to an ideal RSSI, or is it just going to be hot?
Okay, so there's no gain control, and that as per Qualcomm currently is not supported. And really, we did not. It's not like 5 gigahertz. Really, when you go this, if you don't put these units, let's say if you're 10 meters away, you're good to go. So just, it's not good if you put them closer than 10 meters away, then you kind of overdrive the receiver on the target unit, and so that's not a good thing. But we didn't find, actually, even with indoor unit, where we run actually lower power somewhat, but we did not find any issues when we would install those, and they would be within like 20 meters from each other. They operate MCS8 perfectly without any issues.
So some of the problems that I've run across is with some of those grid antennas that are 60 gigahertz, they have gain control in them. So you don't see anything hotter than neg 48 when you're trying to line them. So if you are actually pretty close, because it's a really critical link and you want it to always be up and not fade, they hide the RSSI. It's behind the gain control. You can't actually peak the radio properly because you never see anything less than 48.
Oh, I see.
When you're moving it bottoms out at 48. So you're like, am I there? I don't know. You got to look at the 10-second RSSI and the bit error rates and all that stuff to actually know if it's aligned. But it's really frustrating to not be able to see the true RSSI values. So that's good that it's not obscured.
Right, that's true. How many installations do you have where you have you get to RSSI of minus 48?
Probably, I can actually tell you. I can look it up, but it's probably half of them. Half of them are probably.
Oh, okay, it's good.
Wow.
So you really have a very conservative deployment then.
Yes. Yeah.
Because
we're going building to building, MDU to MDU, and so if that particular MDU is out, that's 100 people out on that particular lane. So I'm looking for the most uptime I can have, and rain is definitely a problem. You don't want to have, every time a rain comes through, a reputation of having slow speeds and emissions and stuff. That is not the reputation you want to get. So being able to peak them effectively and efficiently and fast is important. So
well, you're absolutely right, and we always encourage the customers to, we can support MCS8 up to RSSI of minus 65 dBm. Okay, so it's that robust, but we do encourage our customers not to get to that. We would like them to be at minus 55, minus 54. Those installations are solid and perfect. So minus 48 is really good.
Yeah, that's all we can see on some of them. So yeah.
Well, if you see minus 48, I think you don't want. I mean,
well, the thing is, it could be neg 48 and look good, but when it rains, it will fade because it's not properly aligned.
I see. Yeah.
It fades even faster usually when that's the case. So every time we have a rain event that's really heavy and we see stuff go down, we send the guys out to retune the links to try to avoid that next time.
So how are you guys? Are you lining it by I2? Is that how you're doing it?
Oh well, we look at we log into the radios and look at the terminal and do the monitoring of the interface or the alignment mode on them.
Okay.
So you can do some other tricks, like you're allowed to lock the TX sector on them, and if you do that on both sides and do the alignment, it helps a little bit, but it's not. It hiding the RSSI value is really the downfall. Yeah, that we have, the real big issue. So
yeah, so our link that we've had up the longest, we've been running at an neg 62, and it's been going for months and months and months through rain and storms and everything without dropping anything. So just for perspective.
Yeah. Okay.
Rock and roll. And I mean, that could be also, a product of, I guess, the 128 antenna elements, right?
Yeah. So that, we actually do have, for our customer, we have exactly the measured and extrapolated fade at each and every rain level, at each and every angle, so the customers can look and actually then it goes per MCS level. so you can see what you can get at MCS8 with certain rain, a certain angle. You can go and see what the distance that you should, the measured. We did not measure. We cannot measure at every rain conditions at every angle how the performance is going to be, because it's just going to take us forever. We have to wait for the rain and stuff like that. But we did a bunch of measurements. I don't know if you know anything about Minnesota area. We have a hardware facility in Waseca, Minnesota, which is about 60 miles south of the Twin Cities, and it's kind of more of a rural area. So we have a great area where we can go and measure all kind of things. So our field tests are all being done in Waseca area, where we can go different distances and different azimuth and elevations. So we can provide all that information to our customers so they know what to expect when they install something in the field.
So when you say hardware facility, are you guys doing manufacturing here in the U.S.?
We manufacture in the U.S. We manufacture with a contract manufacturer that's located here in the Twin Cities. So it's all made in the USA.
Rock and roll, man. There's not too many vendors that can say that, so that's pretty cool. All right. Well, we are nearing the end of our time. I have dominated way too much of your time, guys, and I really appreciate it. So right at the end, we usually like to do a wrap-up where I say, Miller, well, I got to point that way because you're that way on the screen. Miller, if folks want to get a hold of you out on the internet, how would you have them go about that?
Easiest way is on the Brothers WISP Slack. I'm on there all the time. I'm very active on there. I'm active a little bit on Facebook. Not a whole lot, though. That's a cesspool.
Yeah, especially right now. Yeah,
it is. I don't.
I'm
it's
done.
so
I'm
bad.
done.
I don't want to go to Facebook, so don't make me go there. So yeah, I mean, that's probably the best way. I also have a blog, dynstatic.net, where I do post some things occasionally. Has been a while, but
all right.
There's a contact me form on there too.
All right, so. Mr. Travis Carter, if you want folks out on the bad internet to get a hold of you, how would you have them go about that?
You can just email me at travis@usinternet.com.
Excellent. Well, I sure appreciate your time today, Travis. So,
yeah, thank you.
Mr. Kelman, if you wanted folks to get a hold of you out on the internet, what's the preferred method?
Email probably the preferred method for me. VZK, like my initial Vladimir's, Z, like zebra in the middle, K, Kelman at Kwikbit.com. Or kelmanv@kwikbit.com also would work. So it's best method to get a hold of me.
Excellent. And Kwikbit.com, you guys actually have a contact form on there as well. So
that's right, and it will get to me. We're a relatively small company, so we're on the same. Most of us are in the Minneapolis office here. Some people are in the Waseca office and the hardware design. But it will anything related to customers that want to get a hold of our equipment, I probably would know about.
Excellent. If you want to get a hold of me, I'm Greg at gregshill.com, where I blog constantly now. I used to say very occasionally, but my new profession, it's got me blogging all the time, which I love. Also, Little Brothers WISP Slack, like Miller said, you can slide into my DMs. That's probably the best way to get a hold of me. So again, everybody listening, thank you guys for taking the time. I'm excited about this equipment. I can't wait to see people start getting in their hands, start doing some. I mean, obviously Travis already has, so he's part of the cool guy club. I just want to be part of it. Just want to get in there with you, bud. And I don't know that I want to see your ice in Minnesota, but it sounds interesting.
Well, you're welcome to come up in February. I'll buy dinner. So
you got it, bud.
Well, yeah, dress warm.
Technically, I'm an SSA, and I'm supposed to travel like when this COVID stuff eventually clears up. So, man, next time I'm in your area, I'm going to give you a shout, bud. So, everybody, questions, comments, please send them in. Contact us at the Brothers WISP. Definitely love to have all of your questions aggregated, and we can send it over to Vladimir and pelt him with all of your demands. And I look forward to you guys having the store open. As soon as we get the store open, I will post the link on all of our normal socials and all that good stuff. So questions, comments, thank you. Guests, Vladimir, Travis, Justin, thank you, and we'll see you guys next time.
Thank you so much.
Thank you very much. Thank you.
Thanks.
Excellent.
Ideas and some good comedy given. If you missed the show already, don't worry, you're forgiven.